Hello, it be me. Yes. Looking for someone who wishes to talk physics. So preferably it'd be somebody who actually knows something about physics and can talk about physics rationally, competently, with some actual knowledge of Copenhagen and other nonsense. Yes, that's me, of course. Being redundant, 'cause that's what YouTube requires you to be. I mean, I could have turned the sound off and then done that part, but yeah, I don't know if I need to go to any extra efforts, really, or should I? Anyway, yeah, I don't even go to the extra effort of pouring some nicotine in my nose before I do this. Hmm. Sorry, I just need a little boost. Yeah. Anyway, really have to get off that shit someday. Someday I'll quit smoking, but it's probably not going to be before I'm dead. Anyway, I'll get to some comments and such and so forth. All right, anyway. All right, I read your theory on your website regarding this free speech zone, kinetic field pressure, and how it relates to gravity and magnetism. In an expanding universe, that's a tricky one. The number of interactions or pressure of kinetic field will decrease over time. Won't this result in a change in the fundamental force of the universe? Of course it would. It really doesn't matter whose universe it is. Einstein's, mine, Newton's, it just doesn't matter. Expansion is tricky, in terms of explaining how that's really possible when the quanta can't do any expanding. Um, it just breaks down, even regular forces break down, especially with my forces being causing gravity. Obviously, it would dilute the forces to some extent, but in some respects, it wouldn't matter. It would sort of be just a slower universe, not necessarily a dead one, or in the beginning. So I guess you could theorize that some things would still be maintainable, but I think the real effect would be in the sense that the radiation spectrum would change, and that would probably break the universe down, because the radiation is so much what frequency stuff is moving at has so much to do with how things are communicated between things. And yeah, I think that would make it a little complicated. But anyway, there's so many ways of defining this whole expansion thing. I mean, I tend to think that the universe is a reflective bubble, like we're an air bubble in a liquid. So the universe has a wall. And so all the light going out of the universe, so to speak, actually bounces back as gravity. And of course, all the gravity that goes out bounces back as gravity. So the energy is conserved in the universe. And that would explain how you can have this rich, diverse equilibrium. I mean, rich and diverse over the millisecond, but over time, it's got equilibrium. And the only way it could be that well mixed, that gravity could be so well mixed that it's even everywhere, would be that you'd kind of have to have a bubble where it's been bouncing around for a while beforehand. So I would argue the universe is, well, I've already argued this, but the universe is a lot older than 15 billion years. And that's just as far as we can see, which doesn't mean much. But anyway, yeah, it is. But I'm just going to say, free speech zone guy. I mean, to me, these are the questions that really just don't matter. I mean, how we got here, in a sense, how something and not nothing, all that. Those are questions that really don't mean anything, in my opinion. The only ones that really mean something is um, what kind of environment has to exist for complexity to exist, and then obviously the complexity that creates life, and then the complexity that creates all multicellular life, and then the complexity that creates neurons, and then this complexity that creates sensation. You know, those are the more relevant bits to this conversation if you're going to expand the conversation. And I think the conversation, as far as I'm concerned, I'm just doing this holy grail thing of a unification theory. I really don't care about an origin theory. I mean, if everything else, all other questions in the universe had been answered, okay, go ahead and let's solve that one. But it's the one that I find the least interesting of all possible questions. So anyway, I know God didn't do it, and that's the only thing that really matters, right? I know it's just a mechanical fart thing of the universe. It's not some sort of intelligent process. It's an unintelligent process. All right, this sets me back a few decades. Just kidding. I don't know what that means, but whatever. I don't even get the kidding part. So when a particle has all its arrows summing to null, well, that's not exactly what I say it does, but okay. It stands still. Okay. If it has all arrows agreeing on some direction, it will go C. Well, yeah, but they don't agree, obviously. They just are the field energy it's exposed to, the radiation, comes from one direction. That's the only way it can gain this change. And through a density of field exposure, the field converts it. So it eliminates all the stuff not running, the stuff not running away, the bullets hit. So if if the bullets don't, there's a bunch of bullets. That's the matter. And they're just sitting there. Well, the bullets running away get away, but the bullets that stay get hit by the bullets, if you get my drift. So anything going slower than going the right way, so anything going the wrong direction, well, it's going to get hit because it's not running away, it's running sideways. So yes, but anyway, yes, what you're saying is okay. I just wouldn't say something like agreeing on some direction. That's just, obviously they don't agree. They're forced into their condition. Since massive particles can't go C, it is due to the fact that more massive particles have more arrows. Right, and we shouldn't be calling them particles, right? Because they're not particles, right? I mean, it's like calling us life forms and then calling cells, single-celled organisms, a life form. It really kind of doesn't make any sense because one of us is, we're made of colonies. It's like we're made of people. We're kind of a city. And you wouldn't call us a people, you know what I'm saying? You wouldn't call a city a people. It's a city. It's a bunch of people in the city kind of thing. So you don't call the hive a bee. And so, yeah, particles, like, I don't blame you. I'm just saying we're so used to using these words, but I just mean that's one of the things that physics has got to sort of fix is a thing that is a collection of particles is not a particle. It's like a school or a clump or a group, or we have to come up with some other word, but electrons and protons aren't particles. They're clumps of particles. All right, it's due to the fact that more massive particles have more arrows, so agreeing becomes more and more improbable. Well, there's no improbability. The fact is that it's just improbable that you're going to be ever in a field of force that'll be sufficient to accelerate you out of your material form. So, but it probably happens like in accelerators, for example, okay? They take matter, three-dimensional matter, electrons, protons, neutrons, or even half of atoms, and they accelerate them. And when they do that, they break and they start to go close to the speed of light. Now, if they ever get them to the speed of light, then they would be light, obviously. So, but it wouldn't be in the form of light in the sense that they would be particles that could be anywhere from gravity to some kind of recognizable form of frequency, but it's likely in the process of their morphing from matter to force that they'll also lose whatever element of frequency they contained is likely also going to be destroyed, and they'll end up irradiating gravity, essentially. I would argue that nuclear bombs release a lot of gravity, a lot of force in a form of invisible photons, so to speak, photons without frequency. So agreement becomes more and more probable. Magnetism in a way. Okay, so this Jonathan Fletcher guy's a butthole. Ken doesn't sit and shag everyone off as cunts and shitheads. This has got to be the silliest remark ever made in the history of the stupid internet remarks. Ken's vocabulary is limited to, nothing but completely grotesque conversation. I mean, to talk about Einstein's name and do things like Einstone, meaning dumb as a rock, and all this kind of stuff, and Richard the Dick, you know, remembers Feynman. It's just silly. It's gratuitous, and like I said, you go on what he calls Edison. All he does is sit and name call dead people because he doesn't have the balls to say that shit to somebody who's face to face with him, right? So you're so full of shit, Jonathan. I mean, you're just so full of shit. I mean, all I have to you just play one Ken video, and you're going to find all these gratuitous insults for people that were his better. Anyway, at least he's a civilized human being. Civilized in what sense? How is he more civilized than me, you stupid cunt? I'm a vegetarian. I'm a lot of things that he might not be. So fuck you. I'm more civilized than him. I'll concede my language isn't any better than his. But I'm happen to call assholes who are actually assholes asshole, and I don't use the word in some kind of lazy manner as he uses it. I mean, I don't bother pretending that Albert Einstein wasn't intelligent. He was wrong, but he was certainly intelligent. This guy is a self-opinionated douche. Well, I hope I'm self-opinionated. And he spelled douche wrong, but I'm not a spelling person, so who cares? But quite obviously, at least I defend what I say with some sort of reasoned argument, where Ken does not. Ken just pontificates, and when challenged, he says nothing. He's afraid. He claims he's won all his debates, and yes, he's quite obviously afraid of a debate. How do you justify that, Jonathan? How do you justify your hero's cowardice? Anyway, so another Jonathan. Well, I'll do this in between comment. This is a much easier style to follow. Your idea holds up. I just don't see where your theory explains any new experiments. Well, I mean, I have done new experiments, so you can say that, but whatever. You can't go by one video. You're not going to get the whole story that way. But anyway, are phenomena that already aren't easily explainable. Explains any new experiments or phenomena that already aren't easily explainable. I don't even know what that means. If they're not already not easily explainable, then why are they even theories? If you can't explain it, then it probably shouldn't be a theory. So you didn't write that very well, buddy. LOL, that's says Jonathan again. What a knobhead. Okay, you been honest about me. I'll be honest about you. Ken Wheeler would wrap you around his little finger regarding physics knowledge. Well, I'm the one with the balls to say, let's prove it. He's the one who's too big a fucking coward. So again, more big talk from assholes, right? Why don't you put up or shut up, Jonathan? You're supposed to know something. You seem to say that you can judge who's smart and who's stupid. So you know what? You really can't do that unless you're smart enough to do that. So why don't you put up? Let's see how smart you are, douchebag. You get angry because you aspire to be him. What, I aspire to be an irrational fat guy? I don't think so. Not even close. I really don't. Obviously, Ken he's got some real, incredible amount of volume. He's got a great deal of knowledge. Not a stupid man, but I'm just saying his arguments are stupid. He's not making good arguments. I think I understand more about cameras than you. I think I understand more about cameras than you. I don't think I don't know. Do you? I don't know. Are we talking about cameras somewhere? Don't talk shit about what you don't understand. I don't even understand what that comment even means. I think I understand more about cameras than you. Where have I claimed to be an expert on cameras? I mean, I certainly know what end the photons go in. I know that photons go into the camera. I do know that. Ken doesn't know that. Don't talk shit about what you don't understand. Now, don't you talk shit about shit you don't understand, douchebag. Again, you're not showing your knowledge here anywhere. And you don't understand about cameras. Wow, that is just so bizarre. I have not made any camera videos on this channel, so I don't know what the fuck this idiot's talking about. Now go watch Theo, aka Ken Wheeler, and learn about physics. I don't know what that. Yeah, learn what? Tesla physics? Tesla, who spent the last 30 years of his life trying to sell the idea of a death ray. And fortunately, no one was dumb enough to waste their money on his crap, because they all knew he was a guy who promises and doesn't deliver. The guy was paid a lot of money in his life to do simple things. You know, they gave him $1 million. Make me a ham sandwich, and he couldn't do it. Take care. Take care, you said, lonely man. XPS, you are entertaining as a piss take. No way this makes sense. Take care, you sad, lonely man, whatever that means. XPS, you are entertaining as a piss take. Yeah, well, whatever. You know, the day I start understanding British faggery, you know, is the day I wear shined shoes. Not likely. You talk more shit than I've ever heard. Well, again, you're demonstrating nothing. There's no quotes here. If it's shit, why don't you prove it to be shit? Why don't you quote it and say, gee, that's a piece of shit right there? But no, no balls again. Just another troll who sits in his little coward, I don't bother doing anything. I just talk shit. You don't even understand your own shit you're spouting. P.S. My insults coming. P.S. Keep my insults coming. I don't know what that means. P.S. Keep my insults coming. I don't know what that means. It's fucking hilarious. If you only understood irony of insults regarding intelligence. Well, why don't you say that to Ken? Again, Ken insults dead people. And he's too big a coward to say those same things to the face, okay, of living people who will defend the nonsense he's talking about people, saying people are crazy because they believe atoms exist. Sorry, you're an asshole and an idiot. A religious kook, quite obviously. That's all you have with Tesla, is a silly conception of reality. Let's see. Laters, you angry old bugger. X. Okay. Well, if X is what we do, then that's what I'll do. I'll just X you eventually. So, yeah, don't bother commenting anymore. I'll just block you. Ken talks a lot. How much better he is. So this is some guy responding to him. To everyone else, at least Gary explains his stuff. Ken is just a big-mouthed, egotistical child. Well, I don't know about the child part. He does look like a very big child, but he does seem to, yeah, he talks a better game than he shows up to play, and that be the truth. All right, so accomplish that without too much trouble. Yeah, probably should turn the fan around or something. Getting hot. Bit uncomfortable today for some dopey reason. I mean, it's much cooler. But yeah, just having a crappy period, I guess. I just tired of it all. Fatigued and whatnot, maybe, or something. I don't know. Probably I'm a little tired, actually. Might be part of it. Look at that, Piero. I wonder if you found a job today. Or got a job today with 3 interviews. And there's just a ton of work out there to just grab up because there's so much work. I don't really see it anywhere. I don't know where you're going to find all these job listings, but I don't find it. The ones I find don't seem to be all that. None of them say something like hard-working guy who can figure it out if he has to, knows some shit, but and who can be given a job and he'll do his best to complete it. Yeah, I can do that. Yeah. So, but they don't do that. Let's see. He said bye for no reason. Oh, I don't know. He comes into the room to say goodbye. That's really weird. They are odd things, these kinds of commenters. Not sure if I'm showing up in chat, but also bye. Whatever. I don't get that at all. I mean, they are odd things, these kinds of commenters. And then he makes comments that are completely odd. He makes two comments and then says bye. I mean, sorry, that's just as crazy as the Ken whores. Crazier, maybe? That might be Tesla crazy. I like Tesla. That's the funny thing. His life story is kind of interesting and funny. I mean, he was a bit of a an asshole in the sense that he just he did like eating in restaurants and playing the finery game, even though he talked about how serious scientists can't be loafers. Well, he was a pretty big loafer, and he insulted Edison for being smelly, and you're just like, yeah, well, maybe that's what you should be. It's a little smellier, a little dirtier there, Tesla. I mean, he talked like, oh yeah, well, I had to dig ditches for a while, but I was a real man for 3 days, so I got another job. I mean, it's just some of his. Tesla was just but I like that he spent his reclining years, taking care of pigeons and that's you got to like somebody who picks up pigeons off the street and takes care of them. But otherwise, yeah, he really was just a bit of a douche. I mean, he, all this talk like he made civilization because why? Because he did a few modifications to a concept that was already known. I don't think that's exactly deserves a Nobel Prize. I really don't. That's why he didn't get one. It's frankly. There was some talk they wouldn't give Edison one, but and Tesla, but that's that's a whole there's always stories. You don't know if any of that shit's true. Realistically. So, all right, what else was I gonna do? So I want to reformulate things. I want to make sure my language is correct. So I'm just going through some of the talking points, and like the thing gravity, and then understanding that gravity is a nuclear force. That is that the thing gravity is affecting is not matter; it's the bits inside the matter. Most specifically, the electrons and the protons, and that through their interaction with gravity, they end up producing this new force called magnetism. So it's it's through the nuclear reaction of gravity that magnetism is created, and the consequence of magnetism is electricity. There's just no way of getting around that. Electricity is the movement of the things that are creating electricity, ironically. I mean, magnetism. So it's the electrons. And you move them, charges. More likely to move an electron than you are a proton, for obvious reasons. But yes, it's their movement that creates the force that is magnetism. Realized in the big world as what leaks into the big world as magnetism. And that's all done through filters. And so the structure of a magnet is the chemistry of a magnet is conducive to the creation of um, uh, a matrix, an ordering of the parts in such a way as to shine all the butt ends or whatever, however you want to look at it. It creates a pattern that nothing can go in without being affected by it in terms of being steered by it into a particular polarization coming out. So something goes in this way and it's going to end up coming out that way. Or it comes in this way or this way, or it doesn't matter how it goes in, it's coming out this way. And that's basically what a magnet does. And I mean, right there, you almost have the whole game in terms of all that's necessary to explain just about everything that's happening. But it's that simple. And like I said, light is the most uninteresting of the players, in the sense that light is just about this frequency thing and the fact that different frequencies will be able to accelerate electrons in a different manner. And it's that different kind of acceleration that will decide paths of electrons and whether they're going to bang into each other and push another electron out and that kind of thing. So that momentum is interesting, but it's not as big a player as the magnetic and gravitational pressure field that's really holding everything together. Light is just it's like a toy in, well, no, it's not a good example. It's like a cork floating in the ocean. The ocean's, yeah, and light is interesting, but it doesn't really give the ocean its character. And so what do I want? Okay, so I am going to do another video on the two slit experiment, just because the Harvard professor guy, he had, I don't know why he did, I mean, everybody has their own lecture style. So he did a lecture on this introduction to quantum mechanics. Then he did the second lecture was basically just a reprisal of what he just did, in a sense, to start off. And in a sense, it almost looked like he's really desperate to rationalize the fact that this won't be rational. So he was almost doing the Feynman thing where he's saying, don't think about it, just do it. And he was making excuses for the just do it part. And the funny thing was, he did the same exact drawing a second time, and this time he's using electrons as an example. And I thought that was going to be interesting, just because there's a catch with electrons. So I guess I'll talk about it. I'm going to do, like I said, I'm going to do a video on it, but I'll talk about it since there's nothing else happening, and I don't. My list is feeling kind of. I don't feel like it. I'm just not coming up with great. Oh yeah, let's do the arrow thing, and I really don't want to do arrows today, but I will if somebody wants to talk about it. So I was thinking about the electron and the photon. So the I'll probably play a clip of him saying it's all the same, and right away I'm like, no, electrons aren't anything like photons. Electrons don't have a frequency innately, and that's so the game is played. You'd almost say that, wow, well, this gives you a huge advantage in debunking this experiment, because if I use electrons, there's no frequency, so how can they do the math? Because the frequency is critical to the creation of the recycling pattern. So if they don't have the frequency, they can't make the on-off pattern, because in the math, because it's critical to have the frequency. And so I was thinking about that, and I said, oh, they must synthesize it somehow, right? They create the frequency out of the width of the slit, or they create the frequency out of some other mechanism. When I thought about it, because I'm saying, well, I don't remember them using different math. But that's what they do, though. That's part of the function. So the function in this case, they say they change the equation subtly in each case, and they change it by creating a wavelength for the electron, and they contrive it out of the electron's speed. So now, so the electron doesn't come at a frequency, so they can't use frequency to create the pattern. So what they do is they synthesize its frequency by giving it a momentum. So they say if you shoot the electrons at a high voltage, that's how you move electrons. Essentially, you create an anode and a cathode, and you basically shoot them to a lower potential in the field, because the electrons are going to do that. They're running away from each other and looking for something positive to go to. So if you shoot them at this higher voltage, essentially, it's electron volts, but it's the same difference. They'll move faster getting to the target. And that faster speed will create a different pattern. So that's the wavelength number now. So by multiplying the speed times a constant, they can create an artificial wavelength. So now they have a number that they'll use just like the wavelength number, and it's really just momentum or speed times a constant. And so they use the Hubble constant, or whatever. Maybe it's the Planck constant. Yeah, so it's the minus 10 to the minus 32 constant or whatever, but it doesn't really matter what they use. But they're just seeking, their momentum number is already a number also based on a constant to even come up with it anyway. It's whatever, seconds per Kelvin or whatever. It's in some stupid, some voltage number. Well, anyway, the point is they artificially make a wavelength, okay, for the electron, even though it doesn't have a wavelength. And the wavelength is just going to really just be how fast they're going. And so that's another thing you can sort of understand in the experiment that's intuitively sensible, that electrons are charged. And you could figure that if I was going to shoot an electron by a magnet or something, the faster I shoot it, the less it's going to get deflected. So that's just like a simple gravity argument, right? The faster I bring something into a gravitational field, the less likely it is to be bent by the thing, it's the field. And so that's just kind of intuitively sensible, that if there's fields being created by the slip material, that electrons are going to move through that field based on the speed they're traveling. So the faster they're traveling, the less or more they'll be deflected on the individual field lines that they're going to traverse. So they're going to do exactly what the photons do, in the sense they're going to interact with the other electrons that are in their way. And if they hit an electron, they'll just replace it. They'll stay, and the electron will go, and it'll gain its momentum like a pool ball. It just depends on the speed, how fast it's going in, how fast the other electron is going to leave going out. And clearly, the faster it's going, the less it can be deflected by the field force, the magnetism of the field. So, I'm catch-22'd on the fact that, speed is going to be this, so in the photon experiment, frequency is the relevant factor, because frequency decides how far. So if I hit something with photons, the idea is it's going to get hit twice. And the idea is that if I hit it once and then it moves a little, it might tend to move back onto the field line, if you get my drift. But if I hit it twice at the right time, then I can push it into the next electron, and then the next electron can readmit the photon. But the point is, it's going to be traveling on a field line. And so that momentum, so the momentum is going to be consistent no matter what color light I shoot. But what's going to change is how quickly they get hit. And that's going to change how much movement there is in the electron itself, and how much you move is equal to how fast you move, right? So if you're in a wider gravitational, well, it's almost the inverse of gravity, so I don't know if that's a great example to use, but you can still understand there's two factors. There's how long amount of time you're in gravity, and then there's how close you are to the gravity. You see that how close doesn't do the argument any good. I'm talking about the speed, And yeah, that's all that'll be relevant, is that, so you can understand that the quicker the photons are coming, there's going to be more acceleration in the electron. So the electron, that's like it's like changing the speed of an electron. So if you use electrons, it's about speed. If you use photons, it's about speed. But the speed is being created by how quickly you hit something in succession, rather than how much momentum each photon has. The momentum of each photon, the momentum of the total amount of stuff that's going to hit you is going to be decided by how much stuff is in there. And with higher frequency light, there's more tons inside a specific amount of time. So that's what I'm trying to get to. So it's the same. Momentum is the key factor in both cases. You're just talking about how long the electron travels before it reemits a photon. And in the case of using electrons for the experiment, the electrons are crashing into each other, where when using photons, they're likely not crashing at as fast a rate, but they're in the field longer, technically. They're moving through the electrons slower, so they're in the field longer, which makes them more vulnerable to being diffracted. I guess that's the way of saying it. And like I said, the frequency of the light will change how fast the electrons, let's say, vibrate on the field line. But I would tend to argue that it's a vibration, a transmission that happens between electrons that results in a photon being emitted by the last electron. Yeah. I mean, that was more more complicated. It's a simple concept, and again, I didn't describe it perfectly articulately, but I think you get what I'm saying. But I'm just saying it's sort of interesting that the two things, electrons and photons, end up producing the same effect, but they're sort of producing it through a different mechanism. And that's kind of just another unfortunate element of this thing, is that, but you can sort of see it, because when the experiment is done with electrons, it's clearly not as good a pattern. Because electrons don't really fly straight, as I pointed out in the previous videos, the last couple. You know, electrons are doing a lot of this as they go somewhere, so they're leasing their way through the universe, and so you will never get as fine, as reliable a distinction in terms of splitting them between light and dark. It will always be a lot fuzzier. This will be a lot more error code in it, where photons do travel quite straight in terms of entirely straight. But again, they're hitting electrons in the field, and those electrons aren't always traveling straight either. But being on field lines, they probably have to they can't do the same amount of leasing when they're on a field line, probably, because the field energy is much cleaner than external random energy. Cleaner in the sense that it has a more rigid equilibrium or imbalance. If there is equilibrium, it's more perfect. If there's imbalance, it's more precise than the random field. Because you're only dealing with two pieces of the polarized field. Again, you're back to the red and black arrows. So you're only dealing with a small percentage of the available energy that's affecting them. Yeah, that's reasonable. I really did have more of an agenda here. I just don't know what it would have been. You know, yeah, I mean, doing comments that was almost going to be the superfluous bit. So I'm a little disappointed I haven't done a little bit better with this video, but I am tired, and maybe that's the problem. Yeah, I mean, when I wanted to make the video, I wasn't tired, and now I'm tired. So that's unfortunate. Uh, yeah, so it's the whole acceleration thing is quite interesting. So on terms of acceleration, it's interesting in the sense that what can be, what you can state is that for something to gain velocity, to be initiated into moving, it's we're back to this absorption thing in the sense that it has stuff inside of it that's in the right polarization but going the wrong way. And one of those wrong way things, like an arrow going this way, or that way, right? The ones going that way are obviously the energy coming in this way can't do anything about. So, and if it hits it head on collision with one going the opposite way, that interaction, all these interactions will create whatever was there ends up getting released and in that direction and in the same polarization as that interior part, and the waste, okay, is reflected, or it's now continues forward in terms of it's owned now by the matter. Um, is that all I wanted to say about that? Yeah, so I'm just saying that so when something accelerates, there's just you can just get this clear idea that it's essentially absorbing something that came in this way, even though stuff is still going to be going in all the directions just like before. It's just the polarization won't be. So the polarization of this thing stays, and it has to something in the other directions, but the same polarization will leave. And it has to leave. One of the two directions are backwards. Yeah, that's what I wanted to say. So it's either so in acceleration, you're either going to reflect it or release it perpendicularly, the old stuff, to gain the new stuff, the new direction. So the new direction is replacing direction, and the old direction leaves with the same polarization that the new piece came in as. Right. So with an electron, black comes in, it stays as red, and it emits black going up or down or reflected. And the reflection is an absorption. So that's the trick, right? You don't think of reflection meaning that you gave something polarization in the other direction, but that's exactly what you did. That's why reflections create polarization, is because reflections are an exchange of polarization. Yeah, that's a big one. When they create acceleration. I'm just trying to think if you can have non-accelerating reflections. I have to think of that about that. Thinking about it. No, I have to think about it in a serious way. It just gets confusing because the thing is made out of is different than the force it's collecting. I mean, the arrows that it's being affected by. And so it's just such a subtle little difference, but you have to really keep it in mind to get this right. This is the red and black problem again. So eventually when I have it all solid, then I won't keep making mistakes in terms of black goes in and red reflects. That's not what's happening. Black goes in, the direction goes red, and the black leaves black. So yes, it's a reflection of the same polarization that went in. And what changed was the red polarization got exchanged. The red stayed, but got a new direction. And the black changed its direction, but kept its polarization. So that's what's happening. One thing keeps in the reflection. One thing keeps its polarization, but loses its direction. And the other thing also keeps its polarization and changes its direction. Yeah, that's the way to say that. and the rest of them are perpendicular interactions. So if one of the tangential bits is converted into one going the right way, it leaves perpendicularly. And obviously it's that leaving perpendicularly that creates the electromagnetic forces that create all the electricity and magnetism. Yeah, but that's just another thing where I have to say it right. In Mendham. Why are you saying in Mendham? Who are you? Well, I'm not really in Mendham. I'm DraftScience. I mean, you scared me for a minute. I said, oh no, I put this on the wrong channel. You had me worried for a minute. These interactions are always at right angles, right? No, well, what I'm saying, they're either right angles or a reflection. So that's the catch. The energy can be reflected, and that can cause acceleration, and there won't be any perpendicular effect. But if they hit pieces in the perpendicular dimension, then the force will be emitted perpendicularly. So it just depends. So you can hit 3 things. You can hit a thing going this way. Well, you can hit 5 things actually, right? There's 6 points in the 3-dimensional world, right? There's front, back, left, right, up, down. So those are 6 points. And the one point you can't go is the one you're going. So if I'm a force coming in, I obviously can't hit the one point that's going the same way I'm going, because obviously it's going the speed of light and I can't catch it. So the only thing I can really do is hit things that are coming right at me. That's one of the points. And then there's 4 other points going left, right, or up or down that I can hit. And those will leave with the force perpendicular. So 4 of the points will create perpendicular release, and one of the points will create a direct reflection. So that's always something to keep in mind, is proportionally, most of the interactions will create perpendicular field creation in the process of acceleration. But whatever it comes out to, 20% of the interactions will create reflection. So these interactions are always right angles, right? Yes, that's the, I mean, I don't mind, people talking about it, but it's just kind of funny because I get ridiculed. See, I originally said tangential because I thought that was a good word for getting the idea that they're on a tangent. Because a tangent always seemed kind of 90-degree-ish to me. Like a perfect tangent is 90 degrees. But then somebody said, well, yeah, things can be only 10 degrees and be tangent. And I'm like, oh, okay, whatever. So I had to use this perpendicular word. But, so yeah. So I'm using the right word. It's the best I can do. I hear you can kick out an inner electron using specific energy X-rays, specific energy X-rays. There's no such thing as, number one, well, specific energy means a specific frequency. So, and let's understand, it has nothing to do with energy. I mean, I've sort of been over this before, but the number of tons change when you change the frequency. And that can have the illusion of being more energy, but in a bit of time, it's not really, it's more tons. So you have to count the tons. Okay, this and this, okay, have different energy because this one's able to hold more tons for this distance. But there's no rule. If I was just to have one, the minimum number, just 2, it would be officially a photon. This is officially a photon of X-rays. This is officially a photon of, let's say, infrared. The energy here and the energy here would be exactly the same. So it wouldn't be any higher energy. So I'm just saying the way they describe this is very deceptive, because you're really just talking about the fact that if you fire more bullets, there's more bullets, quicker. Machine guns fire more bullets. That doesn't mean the bullets themselves have a higher impact. The individual bullets are just individual bullets. If I shoot a rifle or I shoot a machine gun, the rifle bullets aren't weaker than the machine gun bullets. where other radiation types hit other electrons. Well, again, I don't think that you can miss an electron with an X-ray either way, but why would X-rays create core electrons specifically? Well, again, I don't. What is core electrons? Because they hit protons. Because they hit protons. Why would X-rays create core electrons specifically? Yeah, I don't know exactly what evidence there is that X-rays create electrons, but if you break pieces off of a proton, I guess you could argue it could become an electron, but I don't know if they have real evidence of that happening. I mean, I don't know if they, evidence is the tricky part here, right? I mean, I'm pointing out how they can't give you an accurate description of the simplest experiments in physics. These more complex experiments, who knows if they're interpreting their experiment correctly. Create core electron holes. Well, again, I don't know what an electron hole is, so it doesn't mean much to me. I mean, they talk about electron spin. It really isn't spin. It's just orientation. So they talk a lot of shit that what's in a core electron hole? I just don't think there is such a thing, frankly. I mean, there's alchemy involved here to some extent. I mean, all protons and all electrons are in some ways all alike from our distant view. Okay, but one could argue that there probably is something like a high energy proton that is able, okay, when it's in this new state, to hold more electrons. But this again gets back to neutrons and their role. And so it gets kind of complicated when you start trying to figure out exactly what you need in terms of atomic weight to support an electron. So I tend to argue that the parts are rather interchangeable. I mean, you could take 4 or 8 hydrogen protons and put them inside of a carbon atom or whatever, and replace the ones that existed, and they would do just fine. Yeah, well, I've said missing electrons. You're talking about ions, and that just changes the stability of the magnetic connections between the electrons. Obviously, there's stable orbits and unstable orbits in terms of the number you have in them. And so, as I'm arguing, it's magnetic forces, okay, essentially, that are holding the atom together. So if I argue that there's positions where the electrons are, and if those electrons, say there's 5, and at 5 they have like a perfect tension between them in terms of the repulsive force. But if I reduce it to 4, now there's a lot more distance between them, and now their repulsive force is getting kind of weak, and they might tend to dip a lot deeper towards the protons as they're moving, and so their wobble might get incredibly eccentric because now they're vibrating a lot more. So I guess that's why I said there's a lot more releasing. So the more perfect their equilibrium, the balance between them force-wise, the more likely that structure stays like this. And if I reduce it by 1, it probably does this. It probably oscillates in all kinds of directions, and in that state becomes quite vulnerable to a photon hitting it at the wrong moment and fucking its day, or doing exactly the opposite, hitting an electron and pushing it into that arrangement to stabilize it. So I'm just saying that the unstable orbits are both a circumstance for change in both directions, where the change might be that you take the atom that's unstable and it will stick really easily to some other compound because of that instability, because the other compound has the electron it needs, the bonding electron. But I would argue that they're not really orbiting. They're constantly doing this arrow exchange thing, right? So they're constantly moving in, in the sense that the little bits that identify your matter are constantly doing all this stuff. but I don't think there's really a bunch of circular orbits. I think the orbits really are like magnets, where if I put a magnet with north side up here and then I put all the, south side up magnets around it, I can create something that'll stay exactly like that if I don't jiggle it at all. And I could almost pick it up and it would be perfect. But it's just the fact that I can't do it without vibrating it and breaking it. But the tension would be perfect. So I really want to do this with glass, but you take two pieces of glass, put some magnets between the glass, and you can probably do all kinds of manipulations to create all kinds of patterns that are using the tension between the two attractive and repulsive forces. I've already done this with these. Just throwing these little magnets, for example, is very interesting. You take one of these little tiny magnets, you throw it by a big magnet, and you can, it's really kind of neat the way you can make them. You really can get incredibly. You could throw one like this. It'll go around like this, come up this way, and land on the top. Really neat shit like that. And if you take like 3 magnets and put them in positions, you can throw one in, and 1 in 1,000 times you throw it, you'll get some incredible pattern that goes up in the air, does a figure 8, and then comes down, lands. So it's really, I really want to play with that just because it's really quite interesting. In terms of, the force, balances and the momentum changes. But the momentum one is a real easy one in terms of, I have this other magnet where, you have this, so the power of the field, once this gets over the horizon, there's going to be a tremendous impetus to push it. And that little bit of pushes the ball all the way across, okay, and it goes past. It has so much momentum, it gains so much energy from that little initiation into the field, that it actually went past the field force and then had to come back. So it gained huge acceleration right here, shot all the way across here, went past where the field is now decelerating it. So now the field is already decelerating it here. It's decelerated and it has to stop it, and then it has to restart it again to get it back to the neutral. But I mean, the momentum, just because of the momentum, it overshoots the field. So I mean, that's the dampening thing I'm talking about. Often talking about. Ooh, don't put on your hard drive, Gary. Not a good idea. Magnets and hard drives. Don't do that. Ooh, they're vicious magnets. I really have to play around with them because they're so strong. I keep putting magnets in bad places because I got a lot of data storage here. It's kind of dangerous. So I think I answered your question about the atom anyway, and the stability of the electrons and the protons. But so there's all that going on. That's where magnetism starts. Magnetism is invented inside the atom, and it's created by gravitational forces. Gravity goes in, magnetism comes out. It's basically what's happening inside atoms, and it's what electrons and protons are doing. They're converting gravity into EMF. So thank you for that. That inspired an excuse to play with magnets. I love doing that. They really are. It really is quite fascinating. Did I leave some somewhere? Gotta make some more. I got a ton of these little ones, but I want to make hundreds of millions of them and then try to do something incredibly interesting. All their chrome is chipping off, which is annoying. They put this cheap layer of chrome on them. It's a little irritating. I wish they would have just dyed them or something. Have one side that has like a blue dye and one side has a red dye, so I could tell what side was which. That would be helpful. So, yeah, things are still working here, right? Yeah. Okay. Moving right along. Yeah, no one's muted me or anything. It's quite good. We're good. All right, so what else do I want to talk about? Yeah, well, the velocity and acceleration thing of the electrons is just, that's where it all happens, really. Most of it happens. Well, I mean, obviously, it has to happen with the protons, too. I mean, they get moved by gravity just as much as the electrons. Um, realistically. But because they have such a greater density, they happen to produce probably more field energy than the electrons do overall. But that accounts for the fact that that's why the electrons are on the outside and protons are on the inside. Obviously, the thing with more mass has to be on the inside. Well, it'll end up being the inside no matter how you look at it. It's eventually the biggest guy is always going to end up being in the middle, so to speak, of a gravitational arrangement. So, yeah, that looks good. So I did do the Thunderfoot video on the Amendum channel where I insulted him and did that and whatnot just to see if I can provoke. But I think it'd be very good if I can get somebody. So if anybody knows of anybody who does physics videos who seems to have some sort of degree in physics or some sort of knowledge of physics and seems interested in demonstrating physics or talking about physics. I mean, I sent emails to that mathematician guy. I sent an email to that physics girl thing. I've sent emails out, but I just don't get any responses from anybody. I mean, I don't get any takers. But if anybody knows anybody I might be able to provoke into an argument, I would appreciate that. Yeah, well, I don't even know what that means. What science? ? I mean, geez. You really don't want to pay any attention, right? Like, I'm supposed to have banners here that tell you exactly what to do, like subscribe, buy a t-shirt, don't listen to the video, just read the text on the screen and obey obediently. We don't really expect you to watch anything or have to understand anything. I just tell jokes, or I make fart noises, or I smoke my bong, and that's what I do, and that's all the video is. I mean, why would you come here? There's 300, I don't know how many videos there are, but I think there's like 300 videos on this channel. And I just don't understand how you could write such a stupid fucking comment. Yeah, what is the issue? The issue is you're a stupid fuck. And you're going to get blocked because you're a stupid fuck. I mean, too stupid. You can't bother to pay attention at all. Can't do any research, can't look at the home page, can't do anything, right? You're just a stupid fuck. Yeah, okay. Yeah, he flamanged me. Yeah, some kind of smiley face. Yeah, goodbye, asshole. Oh, God. I mean, there really is no point, right? If people go to a channel, it says DraftScience, so they know it's about science. So, and what is like? What is the expectation? I'm going to show up, and I'm going to instantaneously know what of this subject is being talked about, and how it's being talked about, and what's being said. And like I said, you just can't be bothered to pay attention for a little while. Look at the videos and the titles. No, I'll just start talking out of my ass. How very useful. I mean, I suppose I should put something maybe in the title of these live conversations that I should say something like seeking to debate conventional physics. What's a good word for conventional physics? I mean, you can't call it modern physics because it changes every day. I'm so sick of people like, that again, that Yale professor guy who I like him as I mean, I like his style. He's really low key. He's, methodical. I like that kind of stuff, but he's just so irritating. As you see, he makes some comment and he says, they're always ragging on Newtonian physics. Newtonian physics doesn't da da da. And it's so irritating because he was talking about, the two slit experiment and diffraction. And it's like, and it was right at a part where he was talking essentially about what I could argue was just Newton's rings, like the idea that you see this pattern and all the physicists know this pattern must mean wave interference. And obviously Newton didn't say that's what it was. Standard model is just useless as I'm not really arguing the standard model because that has 7 zillion piles of crap in it. I mean, they've even shoved dark matter into the standard model now. Wow, my camera went nuts. I think my computer might have just crashed. I mean, the other one. Let's find out. I don't know why the camera would have gone that berserk. That looks okay. All right, so I guess it's all right. Having some issues with computers. This one can do that. That one can do this. Both of them can't do anything. They can't do everything. So it's really irritating to have to, hibernate one and use the other. And whatever. This doesn't matter. I mean, it's not your problem. My problem. I mean, it's a great advantage in a way, but it's very irritating. I mean, I should complain. I have 2 computers at work. I mean, shit, I'm way ahead of the game. I mean, they work mostly, kind of, some of the time. So anyway, so he was saying, Newtonian physics, blah, blah, blah. And I was like, Jesus Christ. I mean, the diffraction pattern that looks like interference existed in Newton's time. Newton's rings are essentially single slit diffraction, which is single slit interference pattern. Newton was aware of this shit. He just didn't jump to their conclusions. And so it's just kind of irritating that he brings up Newton when Newton knew about it. Newton wasn't ignorant of it. He just wasn't crazy enough to go for some silly, the photon splits in half. Because he's saying, why would a photon split in half going through a single aperture opening? That doesn't make any sense. And interfere with itself. That's stupid. Yeah, that's what Newton would have said. That's fucking crazy. That's what's so funny about this whole thing, because the Young experiment, outside the context of the single slit experiment, might seem interesting. 2 slits, and look, it creates an interference pattern. And so the 2 thing throws the physicist off and say, oh, well, 2 slits, it means maybe the photon split in half. But it would never even occur to you to say something that's stupid if I told you there's a single slit and it's creating a interference pattern. How do you explain it? I mean, it wouldn't even occur to you to say the photons split in half and went through, both the halves went through the single slit. It wouldn't even occur to you to say something that's stupid, right? I mean, that sounds idiotic. So that's the joke of physics, is that it heard about the Young experiment, and it seems like physicists kind of forgot about Newton's rings. We don't want to be bothered even doing a single slit experiment. We just love this double slit thing. It's so much fun. And it's like they weren't even paying attention. And then in hindsight, the Huygens guy, who was a desperately for quantum mechanics, wave theory, he loved the whole Heisenberg uncertainty thing, all this shit that was all unicorns and bibble babble, the Huygens guy loved. And so he came up with this gimmick, this silly, it makes an infinite number of little waves that all interfere with each other and self-destruct, except for the 2 at the end. So now you have 2 photons. So now he came up with a mechanism to create 2 photons in the single slit. But it's obviously a contrivance. It's obviously not a principle because it's not applied anywhere else. And it's so obvious that this is just a jury rig. This is just such a canard. It's such a lie essentially. It's fake physics. It has nothing to do with any evidence that these infinite number. Again, do I really have to explain to a guy who even has just a casual interest in physics? Do I really have to explain that it creates a lot of paradoxes if you start talking about putting infinite number of something in between a fixed distance, that's going to cause some trouble? I mean, you can almost just do like Aristotle kind of physics and figure out that, oh, that's a little bit tricky. Putting an infinite number of things in a confined space, yeah, that's a little dangerous. And yet, they go for it. They go through years of study of physics, and they say, okay, you Huygens, all right, I'll go for that. Infinite, well, it's only a word. Who cares? Infinite number of little waves. Okay. I mean, yeah, really. How can a serious physicist look me in the fucking face and say it's okay to talk about an infinite number of something in a confined space? That makes sense. There's an infinite number of something in that space. That's not really troublesome. And I mean an infinite number of something that's doing something. I mean an infinite number of, I don't know, bent unicorns. Okay, who cares? Yeah, bent unicorns is an infinite number. Oh, yeah, all right, doesn't matter because they can't do anything. But we're talking about an infinite number of something that is doing something. And does that make any sense? No. And I'm sitting here just gobstruck, saying, how can they fall for this? How can why should I have to even argue this? Why shouldn't everybody be on my side saying, oh yeah, we got to fix that. Physics is retarded. That's stupid. I mean, we can't have that on our fucking report card. I mean, that makes us look like idiots. The principle that's never used, infinite number of something inside of a confined space. We sound like retards. And it's just so, again, why I'm just sitting here saying, you assholes will sit there and ridicule me. And you think that makes sense. It makes sense to contrive nonsense to solve an equation. Contrive absolute nonsense. And it's absolute nonsense. Anyway. These walls are funny. Oh, I don't know. I don't like quotes. First you hate them, then you get used to them. Enough time passes, you get so to depend on them. That's institutionalized. Oh, okay. Well, that's that. You like doing quotes from movies. I guess that's from the silly Shawshank Redemption. All movies are silly, but that one was a little bit silly. It was a lot silly, actually. But anyway, and the ending was just so. I mean, it was just so. Yeah, I'm gonna go live in South America and chip paint off a boat. Gee, that's what I'm gonna do with my out of prisonness. Yeah, fuck that. And all that money I stole? No. Well, anyway, it just seemed kind of empty. I found it dissatisfactory. Let me just put it that way. As an ending, it was just dissatisfactory. But the whole thing was just silly. Let's see. Oh, I don't really want to talk about the movie, but anyway, I think it shows understanding of why professors are so unquestioning. Well, I understand what you're saying, but clearly there's a psychology involved, so I'll agree with you. Clearly, because it can't be, like, obviously rationality is being totally raped. And somehow they're like, it's okay to rape rationality. And I guess that's because of the whole Feynman thing and the whole, look, you're not Einstein, so you can't understand this. You have to be me or Einstein, or you're not even going to come close. So don't worry about not understanding this. You're too stupid. You'll never be able to figure it out. And they were always saying shit like that, right? I mean, they were always kind of making it sound like there's smart people who can do this stuff. And even if you're a physicist, you'll never be able to do this because you're not Einstein. There's kind of that's in there too, I think. Because Feynman really had that kind of arrogance. He was like, oh, well, maybe there's an answer, maybe there's this, and maybe. But I don't think any of you idiots could ever figure it out because me and Einstein didn't. If me and Einstein can't find the answer, you stand no chance. And they really did have that kind of attitude. And so I guess everybody gets that into their mindset that the Holy Grail, nobody can find that. It doesn't even exist. Because, yeah, the universe is mushy and weird and preposterous and strange. You know, the Heisenbergs of the world won the day, you know, and they all fell for it. But I mean, it's obviously stupid. I mean, it's 3-card Monte kind of stupid. I mean, you're just basically saying it. Yeah, I stole $50 from Einstein, you know, by not having a ball under the cup, and the asshole thought there was one. You know, like I fooled him, you know, with a simple trick. And it's like, well, you know, how did they get fooled by these tricks? And that's all they are. They're trick. I mean, bent space is a trick. So it's not an answer to why there's gravity. It's a fucking trick. So it is weird. I mean, it's just weird that I knew it was wrong. Okay, just because you know, you know, like I said, all you have to hear is that you're saying, what are they even talking about? These silly prospects that. You know, it's bad enough they made the photon capable of splitting in half, and then they're making the photon capable of figuring out how to have a probabilistic equation about how it should interact with itself. And you're saying somehow it doesn't have anything to do with where it goes through the slit. I mean, the slits have a where. You know what I mean? There's a where. There's close to the surface and there's right in the middle. And none of that matters. The only thing that matters is some probability math they did before they even got to the split or something. I mean, it just doesn't, it's, you know, they Heisenberg, I don't know where to go. Okay, well, let's figure out randomly. It's your turn to go left 40 degrees. That's what the computer says. So you go left 40 degrees. So split in half and then go left 40 degrees. That's an explanation? That's physics? I'm saying, no, it can't be that retarded. So anyway, but yeah, so thank Dr. Quantum. I mean, I'll have to thank, you know, when I get my Nobel Prize, I'll have to thank Dr. Quantum for being such a preposterous liar and giving me incentive to say physics can't be this retarded. It just can't be. So that's the irony of everything. There's always ironies, right? So it's, you know, it's the, you know, you're inspired by the ignorant. You know, it's just, I don't know whether that's good or bad. Yeah, well, I'm just sorry, but yeah, I mean, you know, you just watch all the documentaries on quantum, and you know, when they start talking to Slit and Copenhagen and many worlds and all that shit, you're just like, how can they say this shit with a serious? They got like serious faces, like I'm talking something real, and you're just like, how do you turn photons into the most complex, sophisticated, magical beast in the universe when every single experiment demonstrates a photon to be an idiot? I mean, every time you give a photon a test, it does the same thing. It just, I'm going to point B in a straight line. Fuck you. I mean, that's what photons do. And you know how sneaky electrons are. So that's the other part of this, right? I mean, we know how sneaky a fucking electron is. I mean, even when they created the first TVs, you know, they had to have a huge magnet around the tube to make the electron go the right way, because it wasn't going to go the right. You couldn't just aim it somewhere and it would go there. You had to guide it all the way to the screen, or it was going to fuck up. And it's like, we know electrons are wacky, and you're just like, well, how can people not figure out that wacky electrons are fucking up photons? Can't be any other thing. So anyway, so yeah, I really have to do some more writings. I gotta do the starting over videos and do it, but do them do them better than the last 3 or 4 videos where I just can't I can't maintain my continuity. I always have these little breaks in the logic. And again, it's not that it's complicated. It's just that obviously there's 5 different things that can happen, and so you have to explain all 5 of those things, and then you start losing the big picture because you're getting into the detail of each specific thing. And so it requires a little bit of caution and subtlety to teach this correctly. Yeah. I think that sounds like a good rationalization. It just takes a different kind of thought energy. I suppose that's part of it too. Whenever you're doing this kind of puzzle solving, and it's not a flat puzzle, it's a 3-dimensional puzzle. And in a real sense, that's what this comes down to, because you can't just, your brain isn't equipped to do it like that. You can only do dimension A related to dimension B, and then you do dimension B related to dimension C, and then you can kind of do C to A, and but you can never really do all of them pieces at once. And and then your brain gets stuck on the visual part, but then there's this mathematical part. There's this, I don't mean hard math, I just mean the geometry of things in the bigger picture. So I guess that's really what it is. It's just that you have to understand it as the little picture to understand the electron and the proton, let's say, and the creation of the magnetism. But then you have to convert that into the bigger picture and explain how that creates gravity in what we see, in the fact that it's the protons and the neutrons acquiring acceleration, producing electromagnetism. And in that process, that's going to create acceleration towards this other body that's producing the force that's going to create more acceleration, which is actually the absence of the polarization that will decelerate. So in the one case, you're talking about electrons repelling each other. In another case, you're talking about matter attracting, but not in the magnetic sense. I guess that's the tricky part, right? Yeah. So I guess that's just where my continuity problem is that it's gravity to start with. The electrons and protons turn the gravity into electromagnetism. Now, the electromagnetism has little to do with the gravity of the big bodies moving, but the fact that it created it perpendicularly, that has everything to do with now the gravity being created in the big picture. The big items are not moving in the same way the gravity was affecting the protons and the neutrons. They're moving, okay, because the protons and neutrons are moving, obviously, but because even more obviously, because they released force perpendicularly. to their acceleration, which means they're not producing force ahead of them, which means the other thing is going to accelerate towards them. They're going to induce acceleration in the other body. And it's that induction part that isn't really gravity or magnetism. I mean, it is, obviously, but it's induction. So it's this process of feedback. It's not the right feedback. I don't want to use that word if I can avoid it. It's more like reflection, but I got to be careful what kind of, see, so that's it. That's just it. See, that's the lack of continuity. I haven't figured out what vocabulary I want to use to describe the fact that you're consolidating force between the two bodies when they're moving towards each other, but it's all force that has no effect on neutrons and protons. I mean, electrons and protons, and therefore it can't be relevant. Yeah. It's like a castle of cards, missing one and it all falls apart. Yeah, well, it's a little bit like that, but it's not like it all falls apart. I'm just, I mean, quite obviously, my only contribution could have been to say gravity is a nuclear force. And in a sense, I've said something significant. You know, just the very idea of talking about gravity and recognizing that gravity is not moving big things. It's moving the littlest bits inside of you. That idea itself is valuable. It's just thought food. So I could just take the little things I've said throughout this whole thing, the idea that polarization of force is what creates magnetism, or, you know, that kind of thing. That's all, you know, in my opinion, valuable. So it's not like I just have a bunch of flat cards on the table. You know, not like the whole thing is incomplete because I haven't found the right vocabulary. So I guess I'm just not using House of Cards. Seems like too dramatic a metaphor for my failure. My failure is more like the building is kind of ugly. You know, it's a new building and it's kind of ugly, and I have to fix those things that are hanging off and dangling, and people are asking, why has it got a big dildo hanging off the side? And I gotta explain, you know, it's not supposed to be there. I'll fix that. Yeah, that kind of thing. Well, I just mean that all falls apart and falls apart, or I don't know how I'm supposed to, you know, obviously I haven't seen too many House of Cards that don't fall all the way down. So I'm just saying you know, it's usually the failure is catastrophic. One card doesn't fall off, you know, kind of thing. So, I mean, you can defend your analogy, but I just don't think it's a good analogy. That's all. So, let's see, what else is news? Yeah, I could just talk about the Thunderfoot sycophants. You know, so it's kind of funny, you know, the video is probably going to end up with more thumb down than thumbs ups, but it's just kind of funny, you know, because instead of just conceding that yes, sometimes Thunderfoot's a little lazy, and you know, part of it's not just lazy. I mean, he's just so sure of himself, you know, that he says things that, you know, just not too, you know, not quite right. And certainly he does very well sometimes also. I'm not saying he doesn't do good, you know, it's good to explain some thermodynamics to people, but it seems like that's the only thing he does is thermodynamics, right? I mean, in a lot of ways, it's, you know, he doesn't do anything, doesn't really touch the parts of physics and science that are lost in all of this mushy quanta crap. You know, he's just doing basic stuff like, you know, how many calories are in a pile of dog do. And, you know, that's, might be interesting to some people, but yeah, I personally don't get much out of Thunderfoot videos. It's like, yeah, I could figure out that when the rocket exploded, it probably exploded because there was a malfunction. Yeah, yeah, I can figure that out on my own. Hey, one of the pipes might have broke or leaked. Yeah, maybe that's what happened. I mean, he did a whole long video, and he basically that's all he said. Maybe it was the pipe got cold and it cracked and stuff mixed and it blew up. Yeah, maybe. Wow. You still didn't even really explain though. You still need an ignite. You still need an ignition source. So he didn't. He still didn't explain that exactly. Because even if you mix oxygen uh, and kerosene, uh, it doesn't just ignite. So you still need something to ignite it. He really didn't explain what that would have been. I mean, some little sparky bit somewhere, or something that got really hot. I don't even know if heat alone would do it for kerosene and oxygen. I still think you'd need something more energetic than just heat. Well, I mean, something red hot will always create um, uh, ignition sources if it gets hot enough, because the atoms in the environment will fall on the hot and blow up. And when they blow up, that's essentially fire. And so that could be the ignition sources. Um, Compounds being absorbed in mixing processes that will duplicate the. I guess it's a. I'm trying to think of what fire is in terms of creating the photons and the energy, but yeah, something that creates the energy that's created in like fire decomposition. Yeah. Sugar and some potassium bicarbonate as oxidant ignites with no source. Sugar and some potassium bicarbonate ignites with no source. Well, I don't know how you could do that. I mean, obviously, oh well, potassium is going to ignite anything. So that's potassium benzoate. Yeah, okay. Sorry, I didn't read that right at all. That's reactive in the atmosphere. So that's what I'm sort of saying. Some compounds aren't going to last a millisecond in an oxygen environment or a nitrogen environment or any environment. I'm just saying that kerosene and oxygen won't self-ignite. That's all I'm saying. You could put them in a pile, and as long as you kept them quiet, they're not going to just blow up. That's all I'm arguing, is that you need an ignition source. Well, you're spelling it a lot better than I would even come close. So, I mean, I understand what you're talking about. I just mean that those potassium things are the ones that, they're very volatile. So they burn, essentially. When they oxidize, they burn. So you can't really use, as an example, a substance that burns when it oxidizes naturally. Like kerosene doesn't just burn unless again, you have to do something to initiate the process of the molecular process. I mean, you can, I'm sure they would have, I don't know, made kerosene torches or something if kerosene was volatile enough to ignite with just oxygen. But I'm just saying, it's probably, you need a minimum ignition. That's all I'm arguing. It wouldn't take much, but you need something. So maybe just the static discharges going up and down the side of the ship or something, maybe something like that could do it. But I just imagine they have all that stuff quieted down. So I'd still think you need some kind of static or some sort of igniter. I mean, obviously, like with the space shuttle, it was the hole being burned in the side of the oxygen tank, you know, but it was being burned into the side, so there was an ignition source there. Oh dear, depressurization. Um, yeah, but that's a tricky one. I mean, the explosion doesn't indicate that. Obviously, you can't see it because the explosion happened in some, it happened outside of our view, so to speak. It didn't have some kind of jet that was obviously shooting in one direction and then the rest of it blew up. So it didn't do a space shuttle-y thing. But so obviously, whatever jets or whatever pressure release there was, it happened. It happened at the same time that happened. So there wasn't any collection process that took place ahead of time. But I don't, again, depressurization by itself doesn't do anything. So I'm just thinking it still has to do something. Like, you could even argue that maybe the depressurization created a tear in the metal. The metal started tearing. And I would imagine if you tear metal quickly enough, that might cause a spark or something. Possibly. I mean, there would be a static change in the electric charge of the metal if you all of a sudden put a hole in it. It's going to have a new charge field. And that might have been enough to have a few electrons go fast enough to ignite the mixture. To begin the chain reaction of oxidation, right? That's what it really is. It's a chain reaction of oxidation, and you have to initiate it. But good enough. Okay, well, I think I've completed my task once again. There's some good, it's always valuable me doing these things because I talk. There's a little bit of feedback and something rolls around in my head and something good pops out of it somewhere. Well, I don't know if anything, I don't think, yeah, maybe this one wasn't this. Maybe I didn't really, because I didn't write anything down. So obviously I didn't go eureka. I guess I just understanding my own, I guess that's where I gained insight into the problem, the mechanics of trying to describe this. And so now maybe I can focus more on some sort of lesson plan, some discipline I can apply to how I'm going to explain it, so I don't keep bouncing between the macro and the micro. And I'm able to just say, look, this is the macro part, but just remember this big picture part, right? So we're going to do a little bit of this microscope stuff, but you always have to keep in mind the telescope stuff. Maybe that's it. So that was the value. Yeah. Well, is momentum. I'm just waving my hands here. Well, is momentum. Well, is momentum. I don't know what that means. I'm just waving my hands here. Well, is this momentum? I'm just waving my hands here. Yeah, I don't know what that means. Sorry. I'm just saying that a more complete explanation of the failure of the rocket, I think, would need to include some possible sources of ignition. That's all I was saying. I mean, I wasn't saying anything too dramatic. I just thought, like I said, one of the biggest points I thought was funny about that video on the rocket was the, he kept talking about refueling being the most dangerous part. And then at the end of the video, fueling, not refueling, fueling being the most dangerous time. And then at the end of the video, he points out there hasn't been a failure during fueling at NASA since 1960. So that's pretty, I mean, yes, I would argue that fueling has got to be a time where you don't want to be sitting on the park benches, talking about how cool it looks, watching the oxygen tank get icy. Um, I mean, that wouldn't be a clever thing to do with your time, but um, clearly also they're figured out how to do it quite reliably. And I suppose, as I've sort of pointed out, it's kind of a test of the functionality of the ship. I mean, if the ship can't be fueled without failing, it's certainly not going to last very long when it's flying. So anything that fails during fueling is for sure going to fail when it's flying. So I don't think there's too many cases where something that blew up on the ground wasn't going to blow up in space anyway. So it was going to blow up. I mean, if it can't stand being fueled, it really just can't play space traveler, in my opinion. That seems kind of logical. Yeah, I think it's reasonable enough. So anyway, till next time and such. Thank you and such. And I feel like crap and such. So anyway, till next time.